agent-oriented assurance cases. It just takes a meme shift. Preamble. The approach discussed in this presentation is not part of Raytheon Australia Proprietary Limited policy, process, procedure or practice. I am an engineer. I dig cognitive science. Safety cases versus intent specifications amongst an intercontinental, agonistic if not antagonistic debate. Should our safety claims be of a fashion tectonically and philosophically somewhere between MIT and York University? For economy, assurance argumentation should be integral to requirements and design notation semantics. A range of fallacies are detectable in the case notation literature that deflect from that goal. Is harmonization between rationale and argument possible? Is there a means to provide a unified design rationale assurance notation? Meme mashup. The results of a forensic literature survey, spanning 20 years of GSN literature. Kelly interprets the notion of structured argument from MOD with a graphical tree-based case notation GSN. The tree-based notation GSN aims to act as a means to provide qualification towards safety assurance. The tree structure is often guided by a collection of safety assurance case patterns based upon normative practices. The safety assurance case patterns are otherwise agnostic of presentation mode. Kelly has recommended phased safety cases in an attempt to integrate safety practices within mainstream engineering practices. Safety cases are otherwise an instrument of regulation and not of engineering per se. Leveson counters safety cases with intent specifications. By design, intent specifications are an instrument of engineering and are an attempt to integrate safety practices into the entire engineering life cycle. Leveson claims to have leveraged work from the cognitive sciences, especially Rasmussen-Russo group. Leveson proposes that intent specifications leverages the ideas of ends means and of goal-oriented rationale, which comes from psychology and the cognitive sciences. Leveson frames the goal-oriented rationale using control and system theoretics, which is the basis for STAMP and STPA. STPA essentially acts as a heuristic model to guide the rationale development. U capitalizes on a number of decades of research and applications in the area of goal-oriented requirement engineering. Goal-oriented requirement engineering was influenced by cognitive engineering and science practitioners including Rasmussen. U injects agent/actor formalisms into a goal-oriented requirement engineering notation to allow for expression the socio-technical domain. The notation U introduced includes goal refinement and part-whole decomposition semantics in line with discussion on those topics in intent specification literature. Kelly rejects goal-oriented requirements engineering and its notations as being rationale and not argument. Kelly describes goal-oriented requirements notations as goals decomposed by and/or. Kelly thus entirely missing the evidence that the work by U has richer semantics than just and/or decomposition. The ends-means semantic of goal-oriented requirements comes from the cognitive sciences and is the ends-means Leveson leveraged. Kelly's solved-by semantic is actually simply a euphemism for ends-means. The weighted contribution semantic of goal-oriented requirements engineering allows for goal models to act as inference graphs, which is a mechanism for modeling of beliefs. Contribution is otherwise an analog of the causal syntax of BBN. The inference modeling is not, however, Bayesian. The actor/agent and dependency formalisms introduced by U provide the means to model the socio-technical system. The absence of the means to model the socio-technical system was another reason Kelly rejected Toulmin notation. One cannot otherwise model the socio-technical system in GSN. Kelly rejects Toulmin's notation as too general for assurance cases. Toulmin does not propose an notation, however, Toulmin talks about the layout of arguments. Kelly otherwise advocates GSN on the basis that Toulmin uses a typed argument framework, and the nodes of GSN are also typed. GSN is thus deliberately stunted semantically to be a declaration, and therefore sets the nature of the assurance case in stone. Adversarial counter-argument has been suggested as a review mechanism for regulators who are presented an assurance case. This late application of skepticism appears too late in the process to affect assurance outcomes. Interestingly, the idea of adversarial counter-argument is as likely influenced by the idea of defeasibility, which has been discussed by Pollock. The adversarial counter-argument is applied, however, via a separate anti-goal tree, essentially doubling the size of the argument overall. Other authors are looking at injecting defeasible reasoning into cases earlier but fall short of revising the semantics of the case notations, and continue with the injection of an additional argument burden. The burden is caused by the absence of semantics in GSN for capturing skepticism. Consider work outside of case notations, such as backing undercutting argument frameworks, BUAF, in AI, amongst others. BUAF mash Pollock and Toulmin together to model belief attainment by simply having two agents argue the pros and cons until one or the other agent wins out. More formally, this is the idea of defeasible claims and of non-monotonic reasoning, which captures the progression of the argument. Usefully, the contribution semantics of use goal-oriented requirements engineering notation can be shown to support non-monotonic reasoning. Rushby, interestingly, closes the loop on the rationale versus argument story by noting a distinction between case and rationale. Rationale is, according to Rushby, based upon the idea of defeasibility, and also then of non-monotonic reasoning. Rushby is otherwise advocating that a case is constructed from first-order logic-style assertions embedded into the detailed design. The case is auto-generated out of the assertions and presented to SMT solvers, which are used to qualify the case. The assertion of truthity of sufficiency of the weight of contribution is thus a convenient lie to uphold an appeal to calculus. It otherwise hides from the problem of arguing over non-demonstrable concepts using open sentences. That is all interesting because the attainment, maintenance, cessation, and avoidance of goal-oriented engineering modeling have atomicity and durance. Atomicity and durance allow support for modeling of a system by use of causal logic. To that end, authors have run NUSMV and its SMT solvers, and also PRISM tools over goal-oriented models. That is, early validation of goal modeling has been proposed ahead of steaming into requirements. Heady stuff, because even where model checking has been applied to GSN, it only checks the argument, and not the rationale over the system modeling. Rushby says specifically, however, that non-monotonic reasoning, aka rationale, should be behind the case but not in the case. In the context of the system V, however, this also has ramifications for the decomposition and refinement of assurance goals. Ramifications because since behind the case likely means the upstream goals that need to be decomposed or refined down to assertions at lower levels of the system V. That is, connoting Leveson's discussion on intention and refinement over the enterprise architecture model for intent specifications. Rushby's view otherwise contradicts the idea that case notations can be used for capturing rationale. Case notations certainly do not have semantics to support non-monotonic reasoning. Regardless, over the last 2 decades, GSN proponents have attempted to use case notations in the design rationale capture space, but this has not resulted in a change in semantics of those case notations. Of note, if Rushby's perception of what constitutes a case is framed by what has been promulgated as case notations, then Rushby's stand might simply be a circular argument. Certainly, the claim that GSN is better than X because X does not equal GSN has been used against goal-oriented requirements notations in the case literature. An interesting philosophical question might be, what would Rushby's stance have been if Kelly simply adopted use notation and then focused on the generation of assurance arguments by providing heuristics to support agent-oriented assurance modeling? Despite the intuit of Rushby, GSN proponents eventually argued that GSN is a goal-oriented requirement notation. That is, rationale is not argument but argument is rationale. There is otherwise little depth of engineering science behind the use of GSN as a goal-oriented requirement notation without leveraging off the science of goal-oriented requirement engineering. The science of goal-oriented engineering would, however, place the semantics of GSN at around circa 1990, behind the innovations introduced by Wu circa 1995. In fact, the problems discovered with attempts to integrate GSN into design rational space, post-1998, are akin to the problems in early goal-oriented requirement engineering notations that culminated in Wu's work in 1995. That is, case notations, if they are to be used in design rationale space, are, as of today, 2 decades behind in the evolution of their semantics. Of course, GSN proponents otherwise revisit Toulmin's notion of rebuttal through their use of antigoals. That is, the GSN-based approach suggested gives rise to another flaw in the original argument against use of Toulmin's notation. Antigoals are just euphemisms for rebuttal. On the lighter side, GSN proponents have validated the notions of problem frames and of knowledge frames as a means to support specification correctness. To provide a graphical calculus that also sees an economy of argument over the GSN interpretation of the same approach, take the quality attribute scenario model as a knowledge frame, as suggested by GSN proponents, but model it in a goal-oriented requirement notation that includes agent formalisms. Of note, the Toulmin breakpoint dictates that one need not use procedural arguments if one has established a calculus. That is, no need to re-argue in GSN. So, if argument is rationale, then rationale is argument QED. Now what if memes from MIT and Open University are mashed together? What if safety and hazard analysis is simply an expression of non-monotonic reasoning? Using a lightweight promiscuous derivative of Wu's work allows for various modeling heuristics to be applied. Wu has acknowledged this lightweight version, known as GRL, when he acknowledges the ITUT standard Z.151 user requirements notation. The use of stereotypes, and looser semantics than the original work by Wu, allows for an interpretation of problem frames in the first instance, with an interpretation of STPA over the top. This is achievable because the commanded behavior pattern connotes the themes in the basic control theoretic model Leveson discusses. The socio-technical modeling style of GRL thus allows safety analysis integral to an abstraction of the system that addresses the final criticism of Toulmin's notation made by Kelly. That is, modeling in GRL allows for the explicit capture of concepts that relate to the safety domain, including system models that sit at a useful level of abstraction for both preliminary and architectural justifications. GSN cannot support this integration without taking the final steps to include the full semantics offered by GRL. The contribution link of GRL supports weighted inferences to allow for inductive reasoning over edges. All just visual syntactic sugar for positive and negative degrees of support or attack as a means to engage in a graphical form of non-monotonic reasoning. This semantic element might also have the pedagogical influence on argumenters that is missing from GSN, CAE, UML, and from SysML. Unification. It just takes a meme shift. Using a promiscuous goal-oriented notation that includes stereotyping allows one to argue case-based using heuristics from GSN. The subset of GRL that can be used to argue GSN-esque is circled in red. Mapping GRL to GSN subsequently allows one to map into SAC-M, ARM. The overloading of GRL belief nodes is permissible because belief is the basis for justification, context and assumption, at least in the context of definition of those concepts in GSN, but certainly when epistemological theory is considered. Either the dependency or the and composition relation of GRL can be used to emulate solve-by links of GSN. The dependency link of GRL is a euphemism for ends-means in any event, as is the solve-by link of GSN. The part-whole decomposition of goals in GRL is sponsored by and, or an XOR combinational logic. Kelly rejects combinational logic for goal premises despite combinational logic being a tool of argument. Goals in GSN are silent and based combinations of goal logic, as GSN omits OR and XOR combinations. Using a promiscuous goal-oriented notation that includes stereotyping allows one to argue case-based using heuristics from CAE. The subset of GRL that can be used to argue CAESC is circled in red. The GSN is better than X because X does not equal GSN. Pattern of argument applies both for GRL and for CAE. Since the GSN club specification for GSN accounts for this by use of equivocation, GSN goals are CAE claims, GSN strategy is CAE argument, GSN solution is CAE evidence. Claim argument evidence is, however, as much an abstraction hierarchy to define the strata of an argument. Abstraction hierarchies are a tool of cognitive science and are procedurally used to layer reasoning in goal-oriented requirement notations. The equivocation of CAE sponsored by the GSN Club, and the joint efforts of GSN and CAE communities in the definition of IEEE 15026 and of SAC-M, ARM, hint at the one-sided debate that fails to integrate assurance argument into design notation semantics. Of particular note, neither GSN nor CAE notations can agree on the direction of the arrows denoting the flow of reasoning. Interesting because if one notes justification and explanation are two uses of argument, the direction of the arrows will denote one or the other but not both. Satisfaction of a justification flows upwards. Therefore explanation must flow downwards. If the difference between argument and rationale is the direction reasoning flows over the tree, then GSN was never a justification notation, since that claim is made by CAE notation. That puts into jeopardy the act of simply interpreting the GSN nodes in the CAE sense, since the semantics of flow of reasoning is in the wrong direction. Happily, the flow of reasoning over the GRL contribution link is an analog of the supports, is subclaim of, and is evidence for, links of CAE, more so than the solve-by link of GSN. If a 10,000-foot view is taken, above the apparently disparate academic memes, at ground level, one notices a thread that can be accounted for by cognitive science. Accounted for because the notion of intention and its refinement does, in fact, act as a cross-cutting concern or aspect. Taking first the requirements and specifications, denoted by causal and temporal logic respectively, we note the problem frames accounts for the transformation of requirements into specification via application of a Jensen-style sequent calculus. Jensen-style because one is reasoning over open and not closed sentences. Paired with semantics to support non-monotonic reasoning, one can inject both safety or hazard analysis into the requirements modeling. So, if a notation can reflect both case-based and non-monotonic reasoning, it must be suitable when capturing preliminary justifications. If it is understood that sequent calculi act as a proof or argument, then application of Jensen-style reasoning over a graph containing requirement and hazard interactions, that results in a form familiar to case-based argumenters, becomes a compelling argument for changing notations. The non-monotonic reasoning also applicable since the reasoning is over non-demonstrable outcomes. Quality attributes of a system or system of systems are non-demonstrable given they are generally non-functional in nature. As GSN proponents have qualified the use of quality attribute scenarios, QAS, for capturing reasoning about design decisions, it is useful to note that QAS proponents also lean on architectural tactics, which are feature models that focus on solution patterns for quality attributes. The architectural tactics models of CMUSEI being analogues of the work from NASA on dependability and security, D&S. The means of the D&S model connotes the ends means of cognitive science, and the D&S model is a mainstream response to the domain of non-functional requirements, NFR. The use of the term quality attributes merely an equivocation for NFR. The coup de grace for case notations is that the qualification of QAS, comparing QAS with knowledge, aka problem frames, is that the Jensen-style reasoning can span requirements, through specification, and into design decisions. A coup de grace because the QAS can be captured directly in GRL, whereas it cannot be captured in GSN. To that end, the GSN base approach is information lossy, which might actually account for debate in the case notation literature around problems for both confidence and belief for readers of case notations. So, if a notation, such as GRL, can reflect both case-based and non-monotonic reasoning over architectural features and tactics, it must be suitable when capturing architectural justifications. Given that both GSN and CAE notations can be shown to be a subset of the semantics of GRL, one can make the case that the IEEE standard for assurance argument notations, IEEE 15026, is a subset of the semantics captured in ITUT-Z.151. Given that the argument notation space is actually vaster than GSN and CAE, one could make the point that if the lexicon, syntax, and semantics of a notation was, for argument's sake, one standard deviation from the semantic described in IEEE 15026, then that notation is an assurance argument notation. A final observation is that the semantics of ITUT-Z.151 provides a reference interpretation of the goals set for design rationale capture, for architectural design decisions, as set by IEEE 42010 for systems and software engineering, architecture description. Coupled with the observation that the semantics of IEEE 15026 is a subset of ITUT-Z.151, an important discovery unfolds. A bridge exists between IEEE 42010 and IEEE 15026. That bridge is ITUT-Z.151. Given the preceding discussion, what falls out is that the assurance reasoning over the architectural justification can be weaved into the views and viewpoints of the architectural description and not stand outside as a separate artifact. Concerns held by Kelly about keeping the safety case impact managed by a parallel level of effort, post-design change, in the information lossy safety case, are allayed because the design reasoning is embedded in the requirement and design decisions for the architecture. Recapping the forensic research around literature for case notations, especially where they invite consideration of goal-oriented requirements notations. 1. Kelly and Levison are at odds with respect to the approach for capturing safety arguments, or so it seems. 2. Kelly tries to delineate between rationale and argument, setting case notations against goal-oriented requirements engineering notations in the process. 3. Goal-oriented requirement engineering notations have, as their basis, the same cognitive science roots that Levison leverages for intent specifications. 4. Intent specification literature does not specify a goal-oriented notation to capture the goal-oriented rationale, but that literature certainly does not denounce goal-oriented requirement engineering notations. There may, in fact, be meme blindness at play. 5. GSN proponents recognize the notion of knowledge frames, and thereby problem frames, as a means to capture rationale suitable for user requirements and supporting system specifications. 6. Problem frames, as a heuristic, can coach modeling in goal-oriented requirement engineering notations to capture the progression of the reasoning, leaning on notion of a Jensen-style sequent calculus. 7. The Toulmin breakpoint essentially eliminates the need for procedural arguments in, say, GSN, if the argument is wrought in a graphical calculus, say QAS or problem frames in GRL. 8. Kelly rejected the idea of rebuttal and did not include semantics for skepticisms in GSN. Rebuttal is otherwise encouraged by use of adversarial counter-arguments, by use of antigoals, and later by discussion about defeasible reasoning in the GSN literature. The semantics of GSN notation, however, has not evolved to support any of those concepts. GSN proponents opt to double the size of arguments by arguing the assurance and then the counter-argument in a second argument tree. 9. The ideas of defeasible arguments and of non-monotonic reasoning are A, likened to hazard analysis by Rushby, and B, taken by Rushby to be the nature of the rationale that should sit behind but really upstream of the assertions made during the detailed design. 10. The observation that hazard analysis, including STPA, involves non-monotonic reasoning allows hazard analysis and requirements modeling integral to the lexicon, syntax, and semantics of GRL. 11. This last observation takes us full circle back to the idea of the intent specification as a means to refine and decompose goals through requirements and into specifications and design decisions, but in a graphical goal-oriented notation. In the process, the modeling captures typical safety case patterns in the goal-oriented requirement engineering notation as a side effect of the requirements elicitation modeling. There is no work needed to convince system engineers of the need to model assurance rationale in a goal-oriented notation, thanks to the case notation camp. The problem for goal-oriented requirement engineering notations might be the stigma rationale incurs, since while it is a good idea to capture rationale, time pressures during projects see rationale capture a missed opportunity. That, and Kelly's equivocations around the semantics of rationale versus argument, which have been shown to be at best intuits but not grounded arguments, at least according to another Toulmin principle. But, if there is a certification requirement to capture assurance rationale, why bear the cost of reverse engineering of the rationale into a case notation? Why carry the risk of an incomprehensible argument disconnected from the design? What if the cost of the move is to learn a slightly expanded lexical, syntactic and semantic palette? Ultimately, all is in place to make the meme shift to agent-oriented assurance cases. Some work remains to close the loop, particularly in the area of integration of ITUTZ.151 into IEEE or indeed OMG standards. All hands on deck for the next unification. Thank you for your consideration of this presentation. Enquiries are welcome via ResearchGate.